Good day and welcome to HVAC 342. This lecture is for Lab 8, and this lecture is about variable refrigerant flow systems. All of those are pretty simple, constant volume units. We're going to go through a brief explanation of them and how to set them up in HAP. Again, in our Lab 8, you'll have a separate page that has all the different items that will be pertinent for the VRF system. Before we get started on going through them, keep in mind when I go to a VRF system, we'll actually be heating the building, not using fossil fuels. They may use fossil fuels to make electricity, like some turbines or something, but we'll have no gas typically that goes to the building. With utility companies in various parts of the United States, I know Consumers Energy is one of them here in Michigan. If I have an all-electric building, I actually get a rate decrease in what I pay for electricity, or you're eligible if you sign up for that. So what I'm going to have you do for this particular building, and we'll do this in another lecture when we build our buildings together, is you're going to want to go ahead and make another electrical rate. And you can see at the bottom of this where I'm highlighting here, or going through this here, we're going to have a different electrical rate, and it's going to be a little bit cheaper. So just keep that in mind. We're going to, when we run this building, we're going to use a different electric meter when we have this system for the building. Now the rest of this, what we're going to end up doing is, when I have a VRF system, typically they cannot, the units themselves, the evaporator, the heater that's in them when it switches from cooling to heating, cannot handle the amount of ventilation air that comes into the building and temper that air. So quite often there's a thing called a dedicated outside air system, or DOAS, that's accompanied with that. You'll also see that same type of system if you have certain types of fan coils, or if you have water source heat pumps in a facility, whether it's coupled to the ground or coupled to a boiler and a cooling tower, you'll see this also. But in here, you're going to find the information for setting this up. And what I'm going to do is I want to spend some time talking about a VRF system a bit. And doing that, I'm going to come into Carrier again. And in this case, what I'm going to do is I'm going to duplicate my existing system. Actually, I'm going to duplicate the VVT system that I made because it's got some zones in it. So I'm going to right-click and duplicate it. And when I do that, I'm going to change this from VVT to VRF system. And what that's going to do for us is it's going to keep them right together here. So as I do this, I'm going to go ahead and change my equipment type to terminal units. And I'm going to change my system type to a VRF system right here. Now with VRF systems, I can either go with direct ventilation. In other words, they'd have direct ventilation into the building or into the unit itself, typically like a 4-inch hole, a piece of ductwork. You put a 4-inch hole in the building, put a louver on the outside of it, and run that to the indoor section for ventilation air. But we're going to use a DOAS system, a dedicated outside air system. And note up here, when I go ahead and go to direct ventilation, the DOAS gets grayed out, so we can't do anything, but we're going to activate that. Now, the DOAS is pretty simple. If you look at it, we've seen this before. This is going to be just an air handling unit, and it could be a rooftop unit. When I go through this, I have to figure out if I'm going to go ahead and have a cooling coil or heating coil in it. Ventilation air part of it, that's the purpose of this, is ventilation. I can pick in here scheduled ventilation. I can pick the correct schedule that I was using. And again, I'm just picking one that's probably not the right solution for it. You're going to want to pick one that best lays out the whole building. If I had a heat wheel on it, ventilation reclaim, we did this before. Cooling coil and heating coil. So we're going to go in here, set our set point. Notice our set point 75 here, and notice that it's 70 here. Keep in mind the DOAS is not a unit like we had for a rooftop unit that would be, we're trying to cool it to 55 or 57 degrees and actually cool the space. With these systems here, the VRF system does the space load. The only purpose of this DOAS is to bring air from outside, condition it to a neutral temperature, so when I dump it into the space, I'm not adding more load into the space. So what you can do with this if you wanted to is to change this to 72, change this to 74, and it would be neutral coming into the space there. Humidifying or dehumidifying, ventilation fan. So this is going to end up being the fan on the unit itself. I got to put some fan energy in, and I have to go back to that sheet. I just put in a number just now that's probably not correct. For the duct system on this, we're going to go with just a ducted, and actually there's not a return on this because this is a 100% outside air unit. As we keep going through here, one of the things I wanted to do right now is I'm going to jump all the way over to equipment. And this is for the DOAS unit. On the cooling side, I have to go ahead and say, what is the efficiency of this? So we have to put in some efficiency for that unit, and I'm just guessing at 12. I know there was a number in the lab, so make sure you find that. So that sets the efficiency of the DX system. And the efficiency of the heating side is 100% because we use an electric heat. And we are going to use electric heat with this instead of anything else because we have an all-electric building. All right, zone components. Again, 3 zones. The zones are already made up, just like the other ones because I duplicated that there. So our zoning is done. As far as our thermostats, we have to change these again. It is a little bit frustrating that it always defaults back, but it is what it is, and we can't change it. Once you have those pretty well set up, you can uncheck this. And what's really weird about this is when you go into the different zones, we're not allowed to put exhaust in here. A little frustrating. So with this here, we're going to want to use a similar thermostat that we did on the other one. Under common data here, we put in our supply temperature and our heating temperature. This is DX. As far as this, there's an air source heat pump, or we could pick electric resistance, and we're going to pick an air source heat pump with this. Under terminal units, these are the units, in this case here, these would be like a fan coil unit that would be either put above the ceiling, or they could put a cartridge unit in the ceiling grid itself. And you've also seen where they've had like mini splits in residentials type applications, they can use that style also. But in this one here, again, I can uncheck these and do each one independently if I have different types of terminal types, even though right now they're all fan coil. And we're going to go ahead and put a minimum airflow in here again, and I believe we used the same as before. And we had a lower static pressure for the inside unit. Under sizing data, again, we're going to put in 10% here. And I did realize we haven't talked about these yet. Give me just a second. We're going to talk about how these systems work. And then under the equipment side for the VRF, under the efficiencies, I'm going to leave these the way they are right now, but you're going to want to go through and determine what is my design outside air dry bulb, and the place to find that is under weather. What's really weird is we can't change this design dry bulb for heating though. So this would be summer condition, this would be winter condition. If I change this below 47, Carrier doesn't run. So they've got a couple of issues with this software, and I'm sure it's going to be taken care of in the next version. Now, in addition, we can come into here and we're going to go ahead and put our efficiency in for cooling and then our efficiency for heating. We're going to pick our compressor type, which I talked about. I believe we put in a variable speed scroll on those. What's interesting about these is I need to go ahead and put in what my refrigerant piping length is. So what we need to do is we're going to put this unit outside of the door of the mechanical room out back, and we have to run piping. So we have to figure refrigerant piping, and again, I'll go into that in just a second. And we have to put in our equivalent pipe length and vertical distance. As far as the minimum load, we have to put in what the minimum load is for the system itself. And With this here, I would set this, these units can operate now at like a minus 10 degrees. And I don't believe I had that in the lab, but you can change this to a minus 10 without a problem. And there's no heat recovery with this. And let's go back here. Let's hit all right. And I'm going to hit OK right now and see if this takes everything. So now we've got two systems made. Now, before we go any further, let's talk about VRFs a little bit, if you've not seen them before. VRF systems are pretty interesting. I'm just going to hit the help command. They don't have nearly as much information on these also, by the way. But with the VRF system, first of all, there's a DOAS or a dedicated outside air system that goes with it. Sometimes we'll use a heat wheel for ventilation reclaim. Sometimes they don't. But there's an electric heating coil for this, in this case, a DX coil here. And we're going to go ahead and we're going to bring this tempered air, 74 or 72 degree air, down the ductwork. And we're going to put that near the indoor unit, or it can be dumped. Honestly, it can be dumped right into the space because it's actually neutral. So it can either be put near the return of this unit. I've seen it connected right to the return going into the, if it's a ducted return on them. But in this case here, each one of these fan coiled units, as Carrier calls them, is going to be an indoor unit for the VRF system. Now, the way the VRF system works, and this is not a great drawing by any stretch of the imagination, we're going to have a large condensing unit or a couple of large condensing units outside. Those condensing units are going to come inside with two pipes, excuse me, refrigeration pipes. One is going to be for like a suction line, and one will be for a discharge line. Once that comes into the building, there's going to be a distributor there, or a refrigerant manifold, where those two pipes connect to. Each one of these zones that's out there, each one of these units that are out there are going to be taking from the refrigerant header or the refrigeration distributor. They're going to have two refrigeration pipes that go to each one of them. Each one of these units can pick heating or cooling, typically, and the unit will either provide this, and the inside of here, it'll either act as it really doesn't have a heating coil and a cooling coil. It's going to have one coil in there, and depending on the refrigerant flow, we will have either hot air being discharged or cool air being discharged. So with these systems, instead of having ductwork running all over the building, we end up with refrigeration lines running around the building a bit. So these typically, all the refrigeration lines typically run right down the corridors or in the building. They try to locate these units in a place that's very accessible for them. But just keep in mind, it's a very different system. They're very efficient. Without a doubt, this is one of the largest forces that's coming into the United States right now on HVAC system design. The efficiencies are really high, and you'll see that this system will outperform the other two that are in pretty easily. So back to Carrier. Pretty straightforward. Again, not a lot to talk about with this. You're more than welcome to go ahead and one system that is pretty simple to understand. They've got some good documentation on it is Mitsubishi with their multi-city or city multi-system, excuse me, backwards there. And I will try to find a user's guide on that and throw that into the class too so you can see that. But this should give you enough information to go ahead and set up your VRF system. So thank you and have a great day.